All right, hello everyone. Good afternoon. We are Flex Systems. My name is Aarit.
My name is Vin.
My name is Nathan.
And I'm Rylee.
All right, and let's switch over. The Ford Farms has a product which is Flex Farms. These are vertical hydroponic farms, which we mainly targeted for schools and smaller businesses so they can grow their own like produce and crops, especially for like at school and lunches. It's very useful for them. Oh, sorry, wasn't all right. The problem with these Flex Farms is that they have an issue with maintaining their pH level. Over time, as the products grow, the pH level will fluctuate, and then you have to go and manually add pH up or down solution in order to adjust it and get it to the correct level of 5.5 to 6.5. So we want to create a system that that will automatically adjust this for them, so that way it is easier for the consumers and just less labor. Our main factors that we wanted to consider was that it should be efficiently automatic, to be accurate and precise, ease of use simplicity, and it should also be cost efficient, as these are again for schools.
So this is our final design written in sketch form. So on the far left over here is our pH panel. And so in this pH panel, there is a sensor connected to a water tank. That sensor will read the pH level of the water tank and send a signal back into a transmitter. That transmitter will read whether if the water level needs to be adjusted, have its pH level adjusted again, in which it then sends a signal to the pump system if it does need to be adjusted, in which that pump system will then decide whether if pH up or pH down is needed to adjust the pH inside the water tank. And here is our water tank in the middle, and where it holds 225 gallons, which can help fill the max amount of water in each of the 5 Flex Farms. And here there is also a drain line that is used for draining out the water for deep cleaning, and then as well a water line to refill back up that water. And so on the far right here is a display of our entire system with the Flex Farms, and where there is a valve to turn on and off the water, but there's also a flow meter to make sure all the water is being distributed equally between all the Flex Farms. And there are omnidirectional pumps inside this, attached to this water line, in which not only could the pumps push in water into these Flex Farms, but they can also push out water back into the water tank to be read again for the pH level.
All right, going off of what Lynn just said, this is our...
Teachers and students, I apologize for the interruption. Would the owner of the white Pacifica minivan that is parked in the front parking lot by the gate entrance, please move your vehicle? Again, the owner of the white minivan Pacifica that is parked in the front lot next to the gate, would you please move your van? Thank you.
All right. This is a CAD visualization of what Lynn was just talking about. We've got our 5 Flex Farms here. This is our main water tank. We didn't have water lines coming off, but there'd be a water line coming in and a drain line going out. On this side, these pipes just hook up, those pipes connect, and Ford Farms has their own like proprietary Y tubing that connects each end of the farm that would connect up at different points on this pipe. And then here, physically attached to our water tank, you can see our pH panel. I'll give you a better visualization of that in just a second. So here is just a rudimentary CAD of our pH panel. You've got the CM444 there, which is just like the main brain of everything. It'll display the pH, but it also will communicate to the pump controller here, which is what just controls the chemical safe pumps that we have built here, which would pump either pH down or pH up directly into the tank as needed. And then over here on this side, we've got the, this is just like a formal flow chart version, but it's same thing that Men said. You've got water lines, drain lines, pH system attached with the Mendelssohn sensor hooked up, and then the flowchart design of our pH system.
So yeah, a lot of our products are from Enders and Hauser. For example, our transmitter, which is a 4-channel transmitter, which allows us to hook even more Mendelssohn sensors if if like there's more water tanks added, or if you just want more accurate readings of the pH level. And in the middle is our pH Mendelssohn sensor, which is the CPS11E, which is just a base model Mendelssohn sensor. And in the far right is a pump control unit, which helps manage all the pumps.
Alright, so this last slide here is the cost analysis. So on the left, we'll see a total of about $10,500 for our entire system we just broke down. And on this bottom right here, we have a return on investment type of graph here, and it goes by year. And at about 5 years, so the red is manual for one, and the green is automatic for one. And you can see that the green one catches up because the automatic, due to National Library of Medicine, one of their studies conducted that 20% larger volume comes from automation, which means that you'll get more lettuce per farm and then more value from it. And then so at about 5 years, like I said, the automatic one will break the net value of 0 and then eventually catch up about year 9 to the manual one and then project more. And since the flex farms are about $5,500 per one, and our system will only be installed once for however many you need, then you get a higher return per investment for how many flex farms you actually have.
All right, thank you. Does anybody have any questions?
In your system, how do you determine how much pH or up or down needs to be added based on the water volume?
That is a formula that would just be programmed into the CM444, and then that just communicates based on our water volume, which we have calculated somewhere. I believe it's, is it 225? Somewhere around 225, give or take a few gallons for variance. There would just be a generalized formula for how much pH up or down there would need to, just based on its like variance. Like if it's low, we wouldn't have a value.
So is there a way to keep the water volume constant?
Yeah, so there is, it would be based on the flow meter that we have. If we pump out a specific amount of water, you could calculate the volume based on that and then use that to keep a constant volume at all times. Any other questions? All right, thank you.
Thank you.